Today we're using graphs and tables to solve linear systems. You've done this before, so a lot of it should be review. At any time when you're listening to this, just press stop if you need more time, because I'm going to go through the vocab fast. Systems of equations are a set of two or more equations containing two or more variables. So basically it's just two equations that you're solving instead of just one, or graphing. A linear system or systems of equations containing only linear equations. And the solution of a system is a set of all points that satisfy each equation on a graph. And they are the sets of points where the lines intersect. So when the lines cross, that one point where the lines cross, that's your solution. Okay. Again, if you need more time, which you probably will, to write this stuff down, just pause the video. All right, verifying solutions of linear systems. So if you get two equations and you would like to see if they are a system, if this 1, 3, that's where the point where they cross is true, what you do is you fill in your 1 for your x values and your 3 for your y. So I'm going to do that right now and show you. So if I put 1 minus 3 times 3 equals negative 8. I have 1 minus 9 equals negative 8, which is negative 8 equals negative 8. When it is negative 8 equals negative 8, that's true. So we would say, yes, this line will go through this point. And then we have to see if they're both true. So I have to put 1 in here. 3 times 1 plus 2 times 3 equals 9. I put the 1 in for x and 3 in for y. And then I have 3 plus 6 equals 9, which 3 plus 6 is 9. So since this is true and this is true, then yes, this is a system. Or this is a solution for both of these equations. So I'm going to do the same thing over here. I'm going to put negative 4 in here. Negative 4 plus 6 equals 4 times a half. I know it's scary. Well, negative 4 plus 6 is 2, so we're just going to solve that. And half of 4 is 2, so that one actually checks off. That's true. I put in a negative 4 here, so 2 times negative 4 plus 8 times 1 half equals 1. Well, 2 times negative 4 is negative 8, plus half of 8 is 4 equals 1. Well, that is not true because negative 4, different sign, subtract, take the sign of the bigger number, so negative 4 equals 1. That is not true. So that means that this is a no. Even though this worked, if this one doesn't work, then this is not a solution of this system right here. Okay, moving on. One method of solving a system of equations is the graphing method. And graphing are graph equations and find the point of intersection. So that's where the two lines cross. That's what you're looking for. And we're going to do one right now. So I'm going to move this just a little bit so you guys can see better. Hopefully, maybe like that. Okay, so the first thing I'm going to do is I'm going to graph this right here. I always put in y-intercept form so I can get more points. So I'm going to subtract 2x on both sides. And I get negative 3y equals negative 2x plus 3. Divide by negative 3. So y equals 2/3 x minus 1. Negative divided by negative is a positive. And then 2 divided by 3, I just keep it like that. Because that's my slope, rise over run. 3 divided by negative 3 is a negative 1. So I'm going to start at negative 1. My y-intercept, I'm going to go up 2 over 3. So I go up 1, 2 over 1, 2, 3, put a point there. Up 1, 2 over 1, 2, 3, dot, up 2 over 3. And I can also go down 2, back 3. Down 2, back 3. Down 2, back 3. I'm going to draw a line. And I like to do the whole graph like that so that I can make sure my line's pretty straight. I'm going to do my second one in orange so you can see it better. I'm going to get in y-intercept form. So y equals x minus 2. So I start at -2. My slope is 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. So right there is where I have a solution. 1 over 1. So I can stop right there when I actually cross, because that's the exact point. So my answer to this problem is that point right there, which is over 1, 2, 3, up 1. So 3, 1 is my answer. For this one, I'm going to do the same thing. I'm going to get y alone, so I would subtract x on both sides. So I have negative y equals negative x plus 2, and then I divide by negative. I divide everything by negative, so y equals x minus 2. So I'm going to start at -2. I'm going to up 1 over 1, up 1 over 1, up 1 over 1. Same thing. I kind of have a pattern, so I'm going to go quick. And again, I draw that line. And I'm going to do my second one in orange. I use orange for my second one. So 2y minus 3x equals -1. I'm going to subtract 2y. So negative 3x equals negative 2y. Sorry. I don't want to subtract 2y. I want to add 3x. I want to get my y alone, so I'm going to add 3x on both sides here. Let's cancel that out. So I have 2y equals 3x minus 1. There. Divide by 2, divide by 2, and divide by 2. So y equals 3 over 2x minus 1/2. And I'm going to start at -1/2. So halfway between 0 and -1. I'm going to go up 3, so up 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2. I'm going to go down 1, 2, 3, back 2. Whoops, back 2. Go down 1, 2, 3, back 2. And draw my line right here. And as you can tell, it goes through right there, which is 1, 2, 3, back 3, down 5. So -3, -5 would be my answer. And on the back side, start up here. Cover this up so it's not so overwhelming to you. The previous examples have only had one solution, so this right here is my one solution. That's the only time those two lines crossed. Now we may have more than one. However, here we go. Linear systems can have indefinitely or no solutions, so my MS or NS. And consistent systems are a set of equations or inequalities that have at least one solution. Inconsistent, they don't have any solutions. So this can be one solution or many solution. This is no solution. Let's go down and look at this. You can classify linear systems by comparing slopes and y-intercepts. So if it's independent, the equations have different slopes. So different slopes, that's your key. Dependent equations will have equal slopes and y-intercepts. So let's look at this. The first one it's crossing right here, so this line and this line. It's consistent because it has one spot that it's crossing, and it's independent because they have different slopes. Infinitely many, it's consistent, and it's dependent. Consistent because it's the same line on top of each other. Can't see that right there. The two lines are on top of each other. And it's dependent because the equations with equal slopes and y-intercepts. Same line, so same slope and y-intercept. And let me get this up. No solution would be inconsistent. They have the same slope, so they have the same line and they have different y-intercepts, so they're crossing the y-axis at different points.